Hey everyone, welcome to a new section of Physics in the Flesh on dynamics and Newton's laws. Okay, so for the first problem, how much tension must a rope withstand if it is used to accelerate a 950 kilogram car horizontally across a frictionless surface at 1.10 meters per second squared? So a lot of these problems just boil down to this formula, Newton's second law, F net equals ma, which states that the sum of the forces acting on an object is equal to the product of its mass and its acceleration. Notice in this formula you've got two vector quantities, the net force and you've got acceleration, and you've got a scalar quantity which is the mass. A couple things to note about this formula is that if there's no acceleration, so if an object is traveling with constant velocity, that means A is 0, which means this product becomes 0, which in turn implies that the net force is 0. That is huge. Okay. With these types of problems, another nice trick is that you can rewrite it like this, and you can also replace the left side of this with the actual net forces. And I'm going to show you how to do that in this problem. Okay, so for this problem, we've got a car. There is a rope allowing the car to accelerate. So first things first with any of these problems, you want to draw a picture. Now I know this problem is relatively straightforward and simple, but I want you to get used to doing that now so that when you get to the really complex problems, it's going to become second nature for you to do this step first. Okay, so let's draw a picture. So you've got your road. Again, no art skills required here. In fact, it's probably better if you just keep the picture simple. Okay, so you've got your car on the road. Draw all the forces you have acting on this. So this is going to be our free body diagram. Okay, we've got the normal force going up, right, because the road is pushing up on the car, and it's opposing the car's weight, gravitational force. And we've got a rope accelerating the car, so that's going to be F tension. Okay, whenever it's a rope, usually it's tension, we label it as Ft. Now normally we would have a friction force going in the back, but it tells us it's a frictionless surface, so those are in fact all of our forces. Okay, next we need to define our positive directions. So I'm going to let positive be up and to the right, and although we will only be mainly using one direction in this problem, it's always good to define it in terms of two dimensions. Okay, so here's the thing. When you look at this problem, in the y direction, so the vertical direction, the car is not accelerating, right? The car is not going up and down, accelerating up and down. It's going across the road. It's going forward. So the acceleration in the y direction is 0, which means F net in the y direction is 0. In the x direction, however, you've got acceleration. You've got an unbalanced force here. Okay, so the only acceleration is in the x direction. Okay, so we start off with our handy F net equals ma. Put your vector symbols on top. Now it's in the next step that you can actually drop the symbols. Well, we're dealing only with the horizontal direction, or the x direction, so what is our net force here? Well, the only force in that direction is tension, and it's going in the positive direction, so we drop the vector symbol and we replace it with positive Ft equals ma. Okay, and at this point, it's simply a multiplication problem. Your mass is 950 kilograms, and that mass is being accelerated at 1.10 meters per second squared, which is equal to 1,045 newtons. Therefore, the tension force is 1.04 times 10 to the 3 newtons. This value that we calculated here is expressed to 4 sig figs. We need 3, so I'm going to express this in scientific notation, 1.04 times 10 to the 3, and there is your final answer. Okay, hope you guys enjoyed this video. If you did, be sure to click that like button and subscribe to Physics in the Flesh so you never miss a video from me. Thank you so much for watching.